I think this might be one of my favorite things to teach. It is so much fun as we get to look at Riemann sums, what we call Riemann sums. And so I hope this kind of makes sense. I'm going to use a lot of the ideas from the video that I did where I drew the rectangles and everything. So if you haven't seen that video, I'll definitely put it up in the cards for you. Um, so we are going to focus primarily on calculating Riemann sums from a chart. And we're going to be using particular different types of sums. So let's look first of all at the midpoint sum. We're asked to be approximating the integral from 0 to 25. We have data from 0 to 25, and we want three subintervals. So I want you to recognize that in order to get three subintervals, I'm going to have to go from 0 to 7, from 7 to 15, and then from 15 to 25. Now, to do that, I need to first of all recognize the width of each of my rectangles. So remember, pretty simply, that area, which is what the antiderivative, the integral finds, is going to be width times length or height in this case. Our rectangles are going to be 7 wide. Okay. So you'll notice that this one is 7, then this one is 8, and then this one is 10. So let's start with the width that is 7 first. Okay. We are going to have a rectangle from 0 to 7, and we want the height of that rectangle to be at the midpoint. So we want the height to be 6. Okay, look at the second rectangle then. It's going from 7 to 15, which has a width of 8. And again, we want the height of that rectangle to be in the middle, which would be -10. Our last rectangle will be from 15 to 25, which is a width of 10. And then we want the height again to be in the middle, which will be 8. Now it's simply a matter of multiplying and adding these areas together. So we've got 42, -80, and 80. Now remember, a negative area really is an area that's just located below the x-axis. And so we get 42 there. Let's look at B here. We're asked to do a left-hand sum. And this time we want 4 subintervals, and we're going from 0 to 15 only. Okay, so we're going from 0 to 15. We're not going to include this information at all. And we want 4 subintervals. So pretty easy. We can see that our subintervals are going to go here. Okay. But we want the heights to come from the left. Okay. So our first width is 4, but our height comes from the left, which is going to be 15. Our second width is 3, but our height comes from the left, which would be 6. Our next width is 5, but we want our height from the left, which would be -5. And then our next width is 3, but we want our height to come from the left, which would be -10. So the left-hand sum tells you where you want the height to come from. The left endpoint tells you the height. So we multiply and then we add the areas together. So that's 78 plus -55, and that gives us 23. Okay. Our next one then is a right-hand sum. And we want to go from 4 to 20. So I'm going to mark off the one that's not mattering here. And I want to go with a right-hand sum with 4 subintervals. Okay, so let's see. How do we get 4? Oops, we're not going to use that last one. That's how we're going to get 4. I didn't mark that one out. Okay, so let's see. I've got from 4 to 7, 7 to 12, 12 to 15, 15 to 20. And remember, the height comes from the right endpoint. Okay, so our width here is 3. The height comes from the right endpoint, which is -5. The width is 5. Height comes from the right endpoint, which is -10. The width is 3, and the height comes from the right endpoint, which is -2. And the width is 5, and the height comes from the right endpoint, which is 8. All right, so multiply and add. I've got -15, -50, -6, and 40. So that's -65, and 6 is -71 plus 40 gives me -31. Okay, one more to go. This one wants a trapezoidal rule, and we want to go from 0 to 25. Trapezoidal sum, 3 subintervals. So we're going to go from 0 to 7, 7 to 15, 15 to 25. Okay, so remember with trapezoidal rule, and I'm going to write down the trapezoidal formula is 1/2 times the height, and then we add the bases. So remember in our case, the height is the width of the rectangles because they're standing on end. So I've got 1/2 times my first trapezoid is going to go from 0 to 7. So that's 7. And then we add the bases on the endpoints, 15 plus -5. We're not using the ones in the middle. Okay, so 15 plus -5. Okay, do our next trapezoid goes from 7 to 15. So that's got a width of 8. And our heights are -5 and -2. And then I've got a width of 10 and a height of -2 plus 20. So now you add them up, multiply. So I've got -10 times 7, I'm sorry, +10 times 7 is 70, divided by 2 is 35. -7 times 8 is -56, times 1/2 is -28. And then I've got 18 times 10 is 180, divided by 2 is 90. So it looks like I've got 7 plus 90 is 97. So I hope that helps with our Riemann sums working from a chart. As always, if you have questions or you'd like me to clarify a particular step, please leave it in the comments below. Don't forget to hit that like and subscribe button. That way you get a notification every time a new video is posted. Bye for now.